Hi, everyone. Thank you for joining us for Design Day. We are Team 21026, the Improved Knee Brace for Polio Patients. I'm Brad, the lead systems engineer, and Advania is our other systems engineer. Our mechanical engineers are Jihad, Jessica, and Chase, and our biomedical engineer is Karam. We look forward to taking you through our project today. This is our Design Day poster, and before I continue, I'd like to first acknowledge our sponsor, Robert, and our mentor, Heather, for their continued support throughout this process. The sections we're going to cover are materials and methods, system design, results, and conclusions, starting with the introduction. So I'd first like to show you a video of our sponsor, Robert. Here he is walking with the assistance of his leg braces, which are passive and offer stability for standing up, but do very little strength-wise for stepping up steps or getting out of a seated position. So all the other alternatives are similar. However, the ones that do offer strength for these more complex motions are far too expensive to justify purchasing. So he tasked us with designing something that offered both strength and stability while also remaining cost effective. The solution that we came up with that fulfilled these criteria would be to design our own strengthening device that would integrate with his existing leg braces. This solution would ultimately be more cost effective and allowed him to walk up steps and stand up from a seated position. Up next, I'd like to introduce Chase and Jihad for their section on methods and materials.
Methods and materials. The requirements we need to hit was that the system had to be lightweight, cost efficient, reliable, and durable, and those were given to us by our sponsor. The solution we came up with was a fully mechanical system because it would eliminate the weight and complexity of a computerized system, also while being cheaper and more dependable in the long run because you wouldn't need any technical knowledge to fix it and or batteries to go dead. The design we chose was an enclosed compression spring attached to the thigh structure of whatever brace that it chooses to be attached to, and then transmits force via a cable to a radius at the knee joint, which is called the moment arm. In this moment, attempts to straighten the leg to full extension, assisting with standing and or stepping. A locking mechanism in the spring housing prevents the spring from extending whenever the latch is closed, and that is to provide safety and relief from spring force when he is sitting down. And the lock releases itself whenever he attempts to stand up again. The materials we used was 6061 T6 for all parts we manufactured, as it was cheap and easy to get produced. It was also very strong compared to how light it was. And the cable is 1/8" steel cable, and the screws are 1/4" machine screws.
I am Jihad Ashirawi, and I'm going to walk you through our analysis process. The table here summarizes the requirements verified by analysis, which also include the analysis models and predictions. Our first model is the force analysis model, which is a Matlab code that calculates the moment produced by the system and then compares that with the moment of the weight of the user by using the equations shown below for the spring force and moment. The model predicts that the system can produce a moment of up to 482 pounds-inch when standing from a sitting position. That's about 40% of the moment of the weight of the user. Our second model is the weight analysis model, where by using SolidWorks, we estimated the mass of each part of the system, as shown here in the slides. Finally, we ran a stress and displacement simulation using SolidWorks. The results here shown for the two main parts of the system, which are the housing and moment arm. The results suggest that the deflection is negligible and the maximum stress is less than the yield strength. Hence, the deformation is elastic.
I'm Jessica, and I will be beginning our results section with our requirement verification table. This table shows our requirements and which ones have passed or failed up to this point. We are not completely finished with our testing since we're still waiting for a component to be completed and delivered to us, but the requirements that have passed so far include the assistive requirement, which verifies that the system is capable of producing the moment force required to offer our sponsor 40% assistance in standing as requested. The strength requirement has been passed, verifying that the attached systems on the existing braces are able to support Robert's weight. Our weight requirement has passed since the system weighed in at 0.5 kilograms, which is well below the 1.5 kilograms we needed to stay below. Our inexpensive requirement has passed since one system cost $668, and our mounting requirement has passed since we were able to successfully attach the system to the existing braces. Our extension versus flexion requirement is halfway passed as of now, since the system allows Robert to have a fully extended leg. The braces are able to be manipulated into a 90-degree angle with the system attached, but the springs currently in the system are a little too strong for Robert to be able to fully flex his knee to that 90-degree angle by himself. So we're working on making that work for him.
Hello everyone, I'm Karam and I'll be discussing the results we have accomplished so far with our PBS system. As mentioned earlier, Robert gave us a goal to create a system that can offer him 40% assistance. In testing the system on Robert, we found that the strength of the springs were a little too strong that would make it difficult to fully flex his knee to a 90-degree angle in a seated position. However, this will be resolved as the team have ordered a set of lighter springs that are planned to be used in series with stiffer springs, which will offer less resistance in the beginning of the movement, making it easier for Robert to get the desired angle to stand. Lastly, the team is waiting on the latch components to be completed, which were designed to allow Robert to freely move his legs without interference from the springs. In this video, we can see how Robert is slowly walking with the braces on. However, since the video was shot with the stronger springs, we can see how it is quite difficult for him to bend his knees. Therefore, it is why we see slow and not very smooth steps. But once we get those less resistant springs in, we are confident that the system will be way more efficient and Robert will be satisfied with the brace.
I'm Edvania, and I'm going to talk about the lessons learned and conclusion. So while working on this project, we learned that everything takes longer than expected. When trying to get the quotes for our machine parts from local shops took weeks, and many wouldn't even respond to our requests. We also learned unexpected things would occur. While drilling the holes into the existing brace to attach the system, we ran into a thick piece of hard metal inside, which was unexpected. This pushed back the date we initially wanted to have the system assembled by. In terms of communication, designing the system and trying to communicate our ideas without being able to be hands-on due to COVID-19 led to confusion and uncertainty around design ideas in the beginning. We also learned the importance of being ready to step into a new territory. For example, our team isn't familiar with working with orthotics and didn't have much knowledge on the muscles and joints involved. In addition to that, the team hasn't worked with many of the materials used to complete the system before, so we had some difficulty with assembly. In conclusion, we have designed a Polio brace system which can be attached to an existing brace. We have completed analysis to support our design choices. We have created the system to be lightweight and cost-effective. We have successfully assembled the system and attached it to our sponsor's existing brace. Finally, we have satisfied most of our requirements and are still working to satisfy the rest with our remaining time before delivering the product to our sponsor.
This concludes our Design Day video. Thank you all for listening. Feel free to pause right now to take a longer look at our Design Day poster. Thank you.